in this 3/4 of an hour, I'll be talking about how to survive a long event history. I work for Norwegian Broadcasting Corporation. It's a Norwegian analog of BBC, you can say. I also play keyboard at the band Line Breaker, which is going to perform tonight. So please come if you can. If you like to listen to songs about software, mostly about what can go wrong in software. But first thing first, this is our product. We are a broadcasting company, so we broadcast TV, radio program, news, and our subdomain, where our small group working with, it's publishing content. So everything which NRK makes available for viewers and listeners, whether it's TV programs, radio programs, videos for news clips, metadata associated with all this stuff, we publish it. But my talk has little to do with the actual domain. It's like more general advice, a general recommendation from our experience. Also, it has nothing to do with like C# or F#, which I work with. Typical events and commands which we deal with, just also for you to know what kind of things I will use to illustrate the problem, is like publish TV program, add subtitles to TV program, replace transcoded version, because you can also version video and audio files, update geoblock. Some programs are geoblocked that can't be watched outside Norway. So it's very understandable, I guess, for you stuff. What kind of commands and events that float in our domain. So before we delve into details, by the way, I use word delve, and recently I found that this is something that when they detect when abstracts that people send to conferences are AI generated, there are some words which are used more often than others, and like delve into, actually this is something, it creates some suspicion that maybe this is a AI generated abstract. So somebody like asked AI to create abstract about surviving long event history, and then this is an abstract, and then, so there are maybe higher risks that they reject it. But I use this word, I must say, and then I'm not generated, I'm a real person. So before we delve into that, surviving how long event history, because definition of longevity, even in our software business, varies from the context. Because if you run database transaction, a long-running transaction can be half a minute. Or if you have a workflow manager, a long-running workflow may take a few hours. So what we trying to deal with, actually we will try to deal with indefinite longevity. So when we want events to survive long history, it's not about few years. So we want events to live as long as they can, like maybe a few decades or longer. So there should be no reason why events suddenly can't be played. And also, when it comes to events, also we need to define the scope of what kind of events we, in what scope of event history we're talking about. And you probably suspect that we will be talking about systems based on event sourcing, because if these are transient events that we just generate and send to consumers, and we may store them in an audit log, but basically we're done with them, and then there is not much really to survive, because it's when we want to regularly play back events. This is something that becomes interesting. So who is working with event source systems? Who know? Actively. Not many people. Who is interested in event source systems, maybe as a continuation of the work? So that's promising. It took me many years before I went to event-sourced system. And you can come with a devil's advocate question. Doesn't then systems that are not based on event sourcing, they have an advantage of not dealing with like event history survival? Because if you build your system state from snapshot, then you don't have old events, no survival challenge, no need for this talk. But you all came here, which means that you are worried, I guess, with reasoning behind this event survival, why it can be useful to implement system based on playback of old events. And actually, I think event sourcing doesn't make things more complicated in that respect. I think event sourcing leads to proper event versioning, because we have to face that systems evolve, contracts evolve, and domains model evolve. So we can't expect commands and events stay the same through the years. And actually, event source system becomes much more prepared to that. So regular playback of old events actually it makes this approach systematic, and you can discover early some discrepancies, inconsistencies, and you will be prepared for breaking changes. And then once you learn how to deal with that, actually you have like everlasting system. And on the contrary side, the systems that are based on assumption that we just have state based on current snapshot, often they can't really deal with deal in a sort of good way with contract changes. And there are some evidence that some large systems actually, some features were ported back to support some older versions of commands, something which like you never expect, you never see in event source systems. So, but even if you have long event history, or if you have your event source system, should you keep events long? Because you can still maybe have some snapshots and just create from some certain snapshot, playback newer events. And there is a popular opinion actually that says that you should keep your event stream short. And there may be very good reasons for that. So let's have a quick review of them. First of all, it's performance consideration. So if you have a system where you register millions of events and potentially millions of events per entity, per so-called aggregate root in DDD, you have no chance of like playing them all back when you build the state of your entity. So it's just slow. It can be storage costs. Okay? Everything happens in the cloud these days. So again, if you're talking about like millions or billions of events, then and you don't really need sort of on a regular basis the old one, then this is something to consider. Also, you may have some business, not required, but business process that have entities with just short life cycle. Example is cash register. Like new cashier comes and it's logical to just like start with a new balance. And it's called closing the book pattern. So you don't see really advantage like in business logic keeping old events. Finally, you can have GDPR requirements, and that's a new, or maybe no longer new, but that's reality. You may be obliged by law just to clear old events, or maybe de-anonymize them. However, with all that, if your system actually is not subject to those requirements, then there is no reason why you should truncate your events. So actually you keep your event streams as long as you can, and this is what we do in our system. So there are several reasons for why you would like to do that. Well, first reason is obvious, it's simplicity. Because I mean, if you have a natural events stream, then why should you cut it? Why should you like intervene a natural sequence of events. Just you should have some reasons for doing that. I listed some of them. If you don't have them, don't do it. Also, entities life cycle can be perpetual, so it can be interesting actually to follow the life cycle of entities. I think also very important reason that we can state now, like every second talk at this conference, it's about AI. And when we build systems using AI, often we don't really want how we want, we don't really know how upfront, how we want to use some of the old data. Example is self-driving cars. Like, it's not just that have been working for like 20 years and then now it's self-driving car. It's iterative process. So they have hundreds of sensors. They collect all data they can. And then they try to apply to business logic of electric vehicle and figure out, okay, is it okay now? Does it react on traffic lights? Does it react on temperature sensors? And when something goes wrong, they try to analyze. Maybe we want to use more data, some of the sensors which we haven't been using properly. So you may find problems with your business logic aggregation, and you can correct them, or you may find new ways of using all data. So it's just about like keeping your data foundation active, available to you. And that's, in these days, it's quite important reason. Of course, there is a hybrid approach, mostly for performance reasons, like to optimize performance, to optimize storage costs. You can have a system built with event, playing with event, but you have some snapshots, some bookmarks. Typically, what they do it in the banks. So you have a snapshot computed like every month or every year, and then your account state is computed from events replayed on the top of that snapshot. Bear in mind that it complicates the logic of your system, because you need, in addition to versioning your events, you also need to version your snapshots. And also event payload, they should be small. We'll talk about more about size of events. But state snapshot can be huge because it's a snapshot of the whole state. But that's a totally valid approach. So with that, let me guide you through my opinionated long event history survival guide, which is based on what we experienced in our system, where we have events not very long, but more than a decade long, like 13 years long, 15 years long, so kind of long enough. And we replay state of our entities from those events. So, what should you do to ensure that your events can stay long? This is a guide which actually is not only applicable to long streams. You can also apply to short streams if you keep your streams short. It's just that it gives you bigger chances for event survival if you keep your stream long. So first, we'll go through details of every point. Let me just quickly summarize it. Of course, first, you have to have clear separation between commands, persistent and transient events, because that will help you extract what events you want to focus on when keeping the history. Of course, it's sad to say this in 2024, but separate domain and ETO types. Also, try to define specific events for specific scenarios. We are sometimes overgeneralize things, and we shouldn't do it regarding like event data. Sometimes we want to apply class hierarchies there. Don't do it. Avoid large objects in event payload. It's slightly controversial topic. We'll say more about that. Also, a lot depends on how you serialize your events, like whether you use JSON or Protobuf. Again, we'll come back to it. And be prepared for event migration if you have to. We usually don't migrate event. Like we do it for to clean up code, basically. We'll talk about this as well. So, first, have a clear separation between commands, persistent, and transient events. So you have to be quite clear about your contract ownership, who owns the contract. That will give you a clear picture of who is responsible for versioning and how you should version it. So commands are typically expressed in imperative mode, like publish TV program. They may be accepted or rejected. So you can have a command audit log, but you don't need to accept every command. So it's only once command is accepted, it becomes a law, and then it triggers persistent journal event. And of course, it can be persistent audit log, but that audit log you don't need to care about, like versioning. So we'll focus on persistent journal events. It's internal system events. They owned by team, which makes easier to sort of control them because we don't have responsibility for other teams when we version them, when we refactor them. They're in code usually expressed in the past tense, and they may not be rejected. This is something which already happened. And they provide foundation for event sourcing. They also have transient events. This is something which we publish sort of on the way out. We may store them, like we store them using so-called outbox pattern because we have obligation for other systems to get these events published. So, but this is like temporary storage of them, and then we don't need to care about like, versioning of this event that will survive years, because once they are published, sort of they're done. If we need to replay the whole thing, we can regenerate them using new version, currently acceptable version by their consumers. So you have commands, you have outgoing events, and in our system, we actually split our event journal events into desired state events and current state events. And this comes from, you will find this concept of desired state in Kubernetes, for example. It's like you describe system, how you want system state to be, and then you start fulfilling this, your wish, and then you receive current state events depending on what's happening to the system. And then you calculate the diff. So it's just pure math. Desired state minus current state gives you remaining work. So let me give you example from our domain. Like we have a published media set. Media set, it's a set of files. In this case, it's I guess it's a radio program because we publish radio programs with 2 different qualities. So we assign desired state, and also it means that we need to publish to the cloud what we call origin. 2 remote files. So we assign them to the cloud, and then workers start uploading these files, and they start sending events about file upload. So we receive first successful file upload, and then we can publish media file 1 to consumers, received remote file state 2. We publish transient event about second file, and also we evaluate that now desired state is equal to current state. So actually we can publish media set completeness event. So this is events which are here in the middle column, which we want to version. As you see, it's quite important for you to be very sort of explicit about what your commands, what your outgoing events, so you don't spend your sort of time and design effort on trying to version and prepare for versioning over the years, something that actually will not be really used. So focus on your internal events. Separate domain and DTO types, and this is a bit sad topic because in 2024 you still meet such architecture, and you know, we will not go into details of this, but just my advice, don't. I mean, don't create these domain types that magically will be transformed into database commands and used both in like events and business logic and UI. So there should be clear separation between your domain types and DTO types, and they have completely different purpose. Your domain types, they present your current understanding of the business domain, and they're rich types. If you write your program in Java or like C#, use class hierarchies and use full expressiveness of the underlying programming language. We write our systems in F#. And in F#, there is so-called algebraic data type support. So you have record types, discriminated unions. It's very good, efficient to describe your domain using these two concepts, but it shouldn't be brought into your DTO type. DTO types are tailored for specific versions of specific contracts. They should be lightweight, independent, and they should be based on primitive data types. Who is using Automapper? Okay, few. I hope you're using it correctly, because last time I checked, there were more than 700 million downloads of Automapper. So I suspect there are more people here using Automapper. But I mean, Automapper is a great library, and Jimmy Bogart, who wrote Automapper, is great developer and architect, and he himself tried to help community and described Automapper assumptions at like it's his blog post, the author of Automapper, and then he's very specific in what situation, what context Automapper should be used. So my brain hurts when when I see that Automapper is used in a system just to automatically, magically convert between domain and DTO types. This is not a scenario which was originally planned by the creator of the library. So, define your events for specific scenarios. So try to avoid, we are generalizers. We like to generalize things, but try to avoid general purpose events. And I can give you just example from our project. When we started writing events for uploading files, we came with this received remote file state with like origin type, because we could upload files to different origins. It used to be Akamai, now it's Amazon S3 compatible storage. So, still in the system is a lot of those events. Today, I would have done it this way, because different origins, even though it's just like file storage, but the content of the events may vary. They can come new fields. So, and if you have this general event, it will be hard for you to extend that. So there are some downsides of the general purpose events. Versioning must be applied to all scenarios. So it immediately makes things more complicated. And also it's harder to perform a cleanup in case some scenario becomes invalid, because if you had different events, it would be very easy for us just to clean up things if you see that there is an origin which is no longer in use, and even though we don't want to delete all the events, but in case there is some completely obsolete branch for refactoring, for code cleanup, we may want to do this. And then, of course, we just have same event. We need to analyze each event on the deletion. Also, originally I put also point about that it's harder to query for event for a specific subset, but you shouldn't be doing that, because if you do event sourcing, you should apply CQRS pattern. So you should do query on the other side. So that hopefully is not applicable to your case. So avoid large objects and event payload. This is a little bit of controversial topic because of what I said about self-driving cars. Don't we want to collect everything? So just in case in the future we want to use this information. Maybe. Unlike some other recommendations, this is sort of not strict rule. It very depends on your case, and this is the domain-specific thing. So, but just go through events and look if they contain some excessive information. Because, yes, the content of events should be sufficient to fully rebuild the state of the system. And like with self-driving car, it may contain information that you can use in the future. But bear in mind that it may have significant impact on performance and scalability when you rebuild state of the system. Try to measure it. So that's very important factor. There may be transport and storage size limitations which may bite you later when you change, let's say, from RabbitMQ to Azure Service Bus, and then suddenly you can't replace certain events. So let me give you an example of what I would call it mistake, design mistake. So this is event for completed file transcoding. And video files content, it can be up to 10 gigabyte. So with this information, we just put the reference to file path. At the time when we designed this event, of course, there was no question about putting the actual file. I mean, you don't send 10 gigabytes as a part of your event. But in case of subtitles, so this is file content. But in case of subtitles file, actually, we put not file path, but file content. Because subtitles files is usually quite small. 1 megabyte is really rare. It must be quite a long movie. Often it's just like 100K or something. And why don't we put it here? Because then everything is in one place and we can just send this event around. So, well, first of all, it makes things inconsistent. I mean, both of them are content. Why didn't we do it also this way? But also later, we experienced some problems when we changed some transport. So if you start looking at some size limitations, you will see that some transport actually have quite, they have quite a shortage on maximum field size. Also, that should hint you that these are designed to send events. So if they have such small sizes, so maybe you should rethink your events. What is your event? So with RabbitMQ, it's no problem. Basically, you can send anything to RabbitMQ. But even there, you see, usually with new versions, just they come with larger sizes. But here they came from 2 gigabyte to 512 megabyte in RabbitMQ 3.8. In Azure storage queues, it's always been quite small. In storage bus, depending on standard or premium, you can have up to 1 megabyte. And actually, we have subtitles which is a little bit above 1 megabyte, so they won't fit in any of these Azure buses. With storage, of course, it's much easier. But again, if you use Azure Table Storage, which is very efficient and fast, then you have quite severe limitations. So this is sort of just for you to be aware that just check if you really need your events to be large, because TCP packet size is 64K. Large messages, they cause paging them, and then it blocks sockets, and then things become really slow. So if you have millions of events sending like every hour, be aware of that. Will large events fit onto queues and storage fields? So maybe you can just split your events into smaller events, or maybe you need just to keep them atomic. So this is questions that your business domain expert should answer. But be aware. So in our case, we found out that in most situations, we didn't need events to be really large. So it was just design mistake when they became large. Also, how you serialize events. Often we serialize events using so-called polymorphic event serialization because it just works without us thinking about it. And so polymorphic serialization works very well when it works. When you have class hierarchies, you have class like animal, and you have class dogs, and then depending on runtime information, things can just serialize and deserialize. But you should think then, why? Why should you put notion of your class hierarchies in events? Will it survive? Because you may have a different understanding of how your data are united in hierarchies in a few years, but it will be still the same data. So it's a red light, basically, or maybe yellow light. Think about it. Yeah, usually they use like JSON, XML. They can also use binary serialization. And important thing is that they contain some runtime information. The problem with polymorphic serialization, one of those, in addition to, I think that this is basically design mistake, like to put class hierarchies there. If runtime is upgraded, it happened like in .NET several times. If namespace changes, we actually suffered from that. Like we moved, refactored the code, moved different namespace, and then suddenly our events couldn't be played because, polymorphic serialization cares about that. So use schema-based serialization. So it's just you need to know the schema of your data. That's it. So there is no sort of magic application of runtime type information to that. And there are some great formats which will stay in many years. Like Google Protobuf, which we are using, it's extremely efficient, and it will not go anywhere in 5 or 10 or, well, if anyone is alive, in 20 years. Example of our schema. It's like this, and you have, with our schema, the schema actually is stored along the actual data. With Protobuf, you need to build your schema into your code, but basically in every language, in every platform, you have support for Protobuf. And then, so here's an example of Protobuf message. You see just primitive types. It has a very small message payload size, fast serialization, deserialization, and you have cross-platform compatibility. What I also find is quite useful with Protobuf, that it doesn't care about naming. This is also something that you should bear in mind if you want your events to live in 10 years. Because we are very sensitive to names. I mean, naming things is very hard. And maybe in a couple of years, there will be a new team, and then they may start refactoring events just to get rid of your names, which they don't like anymore. But Google Protobuf only cares about the position of the field in the message. So those two messages, say, both can be deserialized. So you used to have record ID as a string. You no longer use record ID. Now you use user ID. So you need to assign it a new position in your message, and you reserve number 1. It's no longer used. And you can just switch from last name to surname, from birth date to date of birth. So just do it as your current team prefer. So we find it quite helpful in, where the project lives years and years. And event migration. Of course, you should strive for out of the store migration. So the best, if you can read your old events and just version them on the fly. Sometimes it's not desirable, and it can be reasons for that. One of the reasons is to do migrate in store. It's performance and storage cleanup. Like you have completely obsolete events, you just want to get rid of them. You can also have data error correction. So just some events, it's writing history, sort of, we don't like that. If you can sort of change it on the fly, but what if you can't? What if you found that some events were just created with faulty data? That's a valid reason to do in-store migration. And so design your system with support for that. So you should be able to run it. We do it like once in a year to clean up some data which we know that will never be used again, like uploading files to some old origin. Also, you may have some broken backward compatibility. Again, ideally, you should try to resolve these issues on the fly, but there may be new requirements that just incompatible with what you have, and that's, yes, you will have to rewrite the history. And, well, last but not least, elimination of code complexity of technical debt. So as long as you have this old stuff there, maybe you see that, okay, there is too much of your code is dedicated to handling of those old events, and then you may want to get rid of them. Again, it's a this is a practical thing, so you don't need to have it as a requirement for your system. You build your system so it will survive decades, but in some cases you may need to do that. And also one important rule when you migrate your events, it was stated quite long ago by Greg Young, who is actually founder of this conference. A new version of an event must be convertible from the old version of the event. If not, it's not a new version of the event, but rather a new event. This is quite important criteria which you should apply when you think about, okay, are you versioning event or are you creating a new event? Just bear it in mind and apply it to newly created event types. Okay, so with that, I think I've gone through all my personal guidelines of how you can survive a longer event history. I think we have something like about 5 minutes. So if you have any questions, some personal experience which you can share, just please speak up. Questions?